Today we will be doing some tests on copper sulfate. First off, with the materials needed, you need a beaker, a measuring cup, a scale, some threads, a pencil, as well as copper sulfate. Be advised that copper sulfate is moderately toxic. Here, I put in 100 grams of it. Then, using my measuring cup, I measured around 200 milliliters of boiling water. It is important to put boiling water first into the beaker, as we do not want any boiling hot water or copper sulfate solution splashing onto us. Adding my copper sulfate to the solution, you can tell that it's very cloudy because I'm making a supersaturated solution, and there's also a lot of contaminants in my copper sulfate as I bought it as root killer. However, by recrystallizing it, I should be able to remove a lot of the contaminants. To try to dissolve as much copper sulfate into the solution, I mechanically stirred it using a disposable spoon just to try to make the solution much more homogeneous. You can see that there's no solid chunks at the bottom, but it's still very cloudy. Right now, because of the hot temperature of the water, it can dissolve a lot of copper sulfate. However, as I leave it to cool, a lot of the copper sulfate in the solution should precipitate as crystals. A day later, you can tell that the solution is much more transparent. Also, at the bottom, you can see the formation of some crystal seeds. For now, since the solution is just saturated, there's no more crystals that are going to be formed. So now, I'm just going to focus on extracting these crystals from the beaker. I bought a cheap strainer from my local 99-cent store, then put a coffee filter on it. This would ensure that the liquid copper sulfate would filter out any particles or debris that got in there. That also includes the insoluble contaminants that came with the original copper sulfate pack. After filtering out the liquid, you can tell that there's the crystals at the bottom. However, there's this turquoise colored contaminant, which I believe it is, that was getting in my way. It had a similar color to the anhydrous version of copper sulfate, but since it was just in liquid, I was confused why it was there. Since it looked like it was soluble, I used more hot water to try to wash it out. I know that this could have decreased the yield of my crystals, but I did not want any contaminants in my crystals. After giving it a quick shake, I managed to take it out, where I stored it in a separate beaker as I was interested in what it could be. You can tell that its shade was close to the original solution, where it was very cloudy instead of transparent. Now, carefully pouring it out, the crystals were much cleaner than before. By accident, I spilled a few drops of the contaminant onto my table. To ensure that it doesn't get on my skin and cause this burning or stinging sensation, I wiped it away with a towel. Now, putting down a paper towel, I patted down the beaker, making sure that all the crystals came out. You can still see that it's kind of in a shape of a beaker, where I need it to be in a shape of a crystal. Thus, I tried to dry it using the towel, and I crushed it up as well. Compared to the initial powder, it's much prettier, and also it's much more pure. There are crystals of various sizes, where I decided to choose a large one to use as a seed. This seed crystal will be used as the origin for a larger crystal. Now, using a plastic bag, I put in all my crystals and labeled it afterwards. Using my remaining aqueous copper sulfate, I decided to carry out a single displacement reaction. With aluminum being the limiting reactant, I did some simple calculations and figured out I needed 5.6 grams of aluminum. While 5.6 grams of aluminum doesn't seem that much, using aluminum foil, each sheet was so light that I spent hours crunching up these sheets and tearing them down to small pieces. Although I'm doing this because my beaker can't handle a full roll of aluminum foil, I'm also doing this since increasing its surface area should make the reaction quicker. Now, using my chemical use only coffee grinder, I put in my aluminum foil strips and I grinded them up. This actually creates a lot of friction and heat, and it also dulls the blades, so try not to do it. I also did this inside of a bag because sometimes it leaks some powder where it's really annoying to clean up aluminum powder. After grinding it a few times, while I didn't really get it to a powder, I was satisfied with the size of the aluminum foil. So I got some of the aqueous copper sulfate, and based on Beer-Lampert's law, you can tell that it's a much lower concentration as it's much lighter in color than before. Also, while I did put the aluminum foil in it, it didn't really start immediately reacting. You can tell that there's bubbles on it, but since there's an aluminum oxide layer on the aluminum foil, it takes a while. I could have mechanically scratched it or used a catalyst such as a fluoride, but I didn't do it because I was lazy. As time passes, you can see that the solution is getting much more darker. Just a quick explanation here, the aluminum displaces the Cu2+ ions where copper metal is formed and aluminum sulfate is formed as well. So after a while, you get this dirty brown liquid, and while you can still see the aluminum sheets, they're mainly made out of copper. So the texture is very different, and I will show you it later, but you can tell that the color is completely different, and yeah. Some of the aluminum might not have reacted, but you can tell that it's mostly made out of copper because there's this brown kind of tint to it. Also, its rigidity was completely lost and it felt very different from actual aluminum foil. So, aluminum foil is on the right hand side, and on the left hand side we have our imposter. To test if I actually had aluminum sulfate, I put in some baking soda or sodium carbonate. So this is actually very similar to the vinegar and baking soda experiment, as aluminum sulfate is actually very acidic, and I wanted to neutralize it before throwing it out. So you can see I created some sodium sulfate as well as some aluminum hydroxide and carbon dioxide gas, as you can see from the bubbling. So in both experiments, I made the substance much more easier to dispose of, as first off, copper sulfate is very bad for environment, like copper ions especially. It kills a lot of fish each year, and I didn't want that, so I made it copper metal and took it out of the solution, and later on for aluminum sulfate I just made it more neutral using baking soda. While it's not as pretty as copper sulfate, it's much safer for the environment. So now back to the seed crystal. I first got my seed crystal and tied it with a thread to a pencil, and I basically just put the pencil above my beaker where I can suspend my crystal in the solution. This solution is just another supersaturated solution of copper sulfate, which will grow onto the seed. So on the bottom you can see that there's these very tiny specks of crystals, and some of the crystals actually grew onto the seed crystal. And you can kind of see that it's covering the string a bit. So I left it to chill on my shelf, and you can see that a few days later the crystal is much larger than before. Compared to the first time I'd made crystals, it's much more centered around the seed crystal, as the seed crystal acts as just like an origin point for all the copper sulfate to crystallize on. After a week, it became huge. I wasn't really sure what to do with it since I couldn't even remove the string since it was crystallized inside. Some of the crystals actually fell to the bottom of the beaker though, so I still wanted to extract them. Since a lot of time has passed, I'm supposing that all the copper sulfate in the solution already kind of precipitated onto the crystal or to the floor, so I was going to replace my solution. It was supposed to be pure. There was some of that weird turquoise kind of contaminant in there. I washed it with water and I rinsed it again. And again, the concentration of this contaminant or the color of it is much different from the actual copper sulfate on the left hand side. Since these crystals were so small, I had some trouble trying to pat them out. However, using a disposable spoon, I was able to extract them and dry them. I added them to the previous bag of copper sulfate. Now that I retrieved all the small crystals, it was time to renew the solution in which the large crystal was growing in. Solution full of supersaturated copper sulfate. I was then able to just leave it on my shelf and leave it to grow even more. Also, you may have noticed that I use plastic wrap on all my containers, and that is just to keep dust out of my solution. For now, these are my final results, and I'd say it's about 2 times bigger than the original seed. So I was pretty curious on what that mysterious contaminant was. Every time I leave my copper sulfate still, this turquoise powder precipitates from it. So initially, even though it was clear on the bottom, now there's this layer of this powder. So it looks like it's soluble, but after a while it becomes this solid precipitate. So I used this pipette to get rid of the liquid, and I tried to isolate the contaminants. I used a pipette instead of a coffee filter, as the first time I did it, the contaminant was able to pass through the coffee filter as it was sort of soluble. So I added some water to the container and put it on a heating plate, since I wanted to test if it was actually copper sulfate or not. From the looks of it, when it added some water, it had the same color as the actual copper sulfate. Despite reaching around boiling temperatures, I was unable to make this solution transparent. I did everything I could, from turning up the heat to using a strong stir bar, but it kept on maintaining this very cloudy blue color. It looked like the contaminant was kind of floating inside the solution, but other than that, it wasn't really doing much. When I took it out, you can see that it kind of leaves a residue, and after a while, it kind of sinks down to the bottom again. It still looks so similar to copper sulfate, so I used my bench power supply to create an electrolytic cell. Ideally, it should look like this. On the right hand side, there's the positive anode, which the electrons flow from there into the negative cathode. Oxidation occurs near the anode, where the sulfate as well as the hydroxide from water is absorbed there. On the left hand side, the copper ions as well as hydrogen ions form copper metal and hydrogen gas. Since I do not want to damage the alligator clips themselves, I use these carbon rods, which I retrieved from batteries, as electrodes. The red is connected to the positive terminal, which means that it's going to be the anode, and the black cable is connected to the negative terminal, which means it would be the cathode. Since current is flowing here, this means that there's ions in the solution and is thus an electrolyte. You can see that there's already bubbling at the anode. Increasing the voltage or the current should make this reaction much more vigorous. However, making it too strong may make it so that the carbon rods deteriorate too quickly. On the anode, you can tell that there's way more bubbling here, and on the cathode, you can see that there's something forming on the electrode. After letting it run for a while, I turned off my bench power supply and let it settle. You may have noticed that the solution is much clearer than before. This is because there's less copper 2+ ions in the solution. Copper 2+ ions have an ionic lattice in which individual water molecules are able to be trapped in there, creating blue compounds or blue solutions in this case. After turning off the power, the copper easily slid off the cathode, where there's still some of this copper metal remnant on the electrode. On the other hand, anodes are notorious for getting destroyed because they have to survive this very harsh oxidation. The cathode has some copper buildup, and on the anode, you can see that it got damaged because of all the bumps. That's basically it for this video, so thank you guys for watching. In the future, I might make some Schweizer's reagent or copper carbonate from copper sulfate, so until then, stay tuned.